Hello and welcome. I am continuing this week breaking down the problems from the Microsoft Excel World Championships finals. Today I'm going to be tackling the semifinals case called 500 based on the card game of the same name, which I didn't know. I'll give you a brief introduction to it. Still don't know it all that well, but I know enough of it to answer the question. By Tim Heng, who was also one of the hosts for the competition. All right, so let me give you a quick introduction to 500, possibly riddled with errors, but like I said, it's enough to answer this case. So basic idea: you've got four players. Maybe you can play with different numbers, but in this game there's four players. Each player gets 10 cards. I'll explain exactly how in a little bit because that's part of what you have to figure out in this case. But for now, let's just say each player gets 10 cards, and the players play 10 rounds where each one puts down one card and they figure out who wins. Now, the actual gameplay does not come into this question, but before they start the game, the players go through a bidding process, and that's what this question is all about. And the idea of the bidding process is basically you try to predict how many hands you will be able to win. And all you need to know about the hands is there's going to be a trump suit. So one of the four suits will be designated as the trump, and based on the trump suit and what cards each of the four players put down, that decides who wins based on seniority or ranking or whatever. So the key thing here is basically each player has to figure out how many hands do they think that they will win if the trump is spades like this, or if it's clubs like this, or if it's hearts, or if it's diamonds. And then you figure out what's your best suit, what's the most hands you think you can plausibly win, and then you make a bid based on that. So let's start with the logic. I don't know if this is a kind of standard part of the rules or if this is just a simplification for this game, but the logic that we're going to use is to figure out how many hands you think you're going to win. For a given trump, we've got three sets of cards. We've got big trumps, small trumps, and aces. So the big trumps are the joker, which is designated JJ, the jack of the trump suit, and the jack of the other suit of the same color. So if the trump is spades, the jack of clubs is also a big trump. If the trump is hearts or diamonds, then those two pair off. So the opposite one of the same color. And then the ace, king, queen of the trump suit. Those six cards are the big trumps. And then the 10 down to 4 of the trump suit are the small trumps. And then you've got the aces of everything except the trump suit. So the ace of the trump suit is up here, all the other aces are down here. And basically we put a value on each of these, which is each big trump is worth 1.25, each small trump is worth 0.75, and each ace is worth 1. And so you add those up and you figure out, okay, that's your kind of estimate for how many hands you could win if that is the trump. And if that's, you basically bid a card. So you can bid the 6, 7, 8, 9, or 10 of spades, clubs, diamonds, or hearts, according to basically, if you bid the 6 of clubs, you're saying, I think I can win 6 hands if the trump is clubs. And so you'll figure out your maximum bid. So maybe you think you can win 7 hands if it's a spade, or maybe you think you can win 9 hands if it's a diamond. And so those, then these would be your available bids. And then the idea is you bid your lowest available bid. So in this case, you'd start by bidding because sorry, I should explain. These are the values of each bid. So generally speaking, higher card value, higher number is worth more, but also the suits are ordered. So the spade is the least valuable, then club, diamond, heart. So the lowest of the values you'd have available here is 40. So you'd bid 40, then if somebody else bids something higher, you have to beat them. You bid the lowest thing that you have that will get ahead of them. And I think that's basically all you need to understand to do the case. So I'm gonna dive on in. So this is one of those cases where you can definitely get a decent chunk of the way by kind of solving this one in a few cells over here, solving this one in a few cells over here. But by the time you get down toward the end, that gets pretty messy. So I'm going to do this. I'm going to break it out on a separate sheet. I'm going to lay everything out in kind of enough space, and then I'm going to do a data table to kind of run that for all the different possible sets of input cards. So let's start. First thing I'm going to do is have a picker. I'll just put in example 1 for now. So this is going to, basically the idea is I'll look up a set of cards according to a game. So let's just start by saying XLOOKUP this, Now I can't just select the column because there's lots of merged cells here. So B to B, and then return from, I want these columns here. So G to AW. So those are the 43 cards that were dealt. Now, the first thing I'm going to want to do is assign those to players. So the way that happens is, well, it's explained here. I'll just show you. The idea is you deal 3 cards to player 1, then you deal the next 3 cards to player 2, then you deal the next 3 cards to player 3, then 3 to player 4 until everybody has 3 cards. Then the next card, the 13th card, you put in the middle. Nobody gets that card. Then you do 4 cards each. So 4 to player 1, 4 to player 2, 4 to player 3, 4 to player 4. Then you drop another one, which I guess you're at 30 by that point. You drop another one in the middle, and then you do 3 to each player. Again, 1, 2, 3, 4, and then you drop the last one in the kitty. So ways to model this, probably the easiest is just to kind of do it here. So I'm just going to, I'll center these so that I can see them next to each other. So that's 1, and then just add 1 to that, copy it across to 9 cells. So that's everybody getting 3 cards. Then that one goes in the middle, which is called a kitty. So I'll just put a K there. And then again, this player gets 4 cards. That plus 1, carry it across until you get up to 4. Then this goes in the kitty. Then you get 3 ones here, and then that plus 1 until last, and that's the kitty. Okay, so that's kind of how you tag each of the players, and then it's just going to be P2, P3, actually I'll just 1, 2, 3, 4. Then you can just filter on the cards. I'll lock that in where this equals that. And that gives you each player's cards. Now the second thing that's going to be helpful to lay out up front is what are each of the trumps in each case. So here are my suits. So let's see, I'll just space it out a little more. So I want my big trumps. I think I said I have 6 of those. My small trumps, I've got 7 of those. And then I've got 3 other aces. And these are worth 1.25. These are worth 0.75. And these are worth 1. So first big trump for everything is going to be the the joker, I mean. Then we're going to have, I'm going to try and be a little shorthand with this. So we're going to have jack, king, queen, and ace, all of the trump suit. And actually I could even take that a step further and extend that. Whoops, one more. There we go. And then I just need to record. Let me just put it here. So this is suit, and this is the opposite suit of the same color. So spade and club swap, and diamonds and hearts swap. And I'm actually going to steal, there's some formatting, conditional formatting here that's showing the colors. I'm going to carry that over. Ooh, that's a little bit gigantic. Let's shrink it down. I'm actually going to work with these, and then I'll take that and put it over here as well. Okay, so then, sorry, my last one is jack of the opposite suit. Then my small trumps are a sequence of 7 starting from 4, and the suit. So no, that's 4, 5, 6, 7, 8, 9, 10 are all my small trumps. And then the aces, I guess I'm going to say filter this where this is not equal to this. So I'm locking in the columns here. So basically I'm saying give me all the other suits. Then I'm going to need to transpose that, and then put an A in front of it for ace. Again, you could do all this manually, but it's slightly more elegant to lay it out this way. Okay, so then you've got all that you need there to figure out the bidding. So now let's figure out player 1, 2, 3, 4, and suit is going to be these suits. Let's figure out for a given suit, for a given player, how many do they think they can win? So how am I going to do this? Well, let's say I'm interested in player 1, suit spades. Basically what I want to figure out is how many of each of these cards does player 1 have? So let me just do a longhand here first. So I'm going to say count if on here from this, and then I'll lock this in. So then I can see, okay, he's got one of these, and one of these, and one of these. So now what I can then do is, rather than doing that in each different cell, I can do one array formula that will return the array of those. And then all I'm going to want to do is take the sum product of that with the points for each one, which is there. And that'll tell me this person gets 3 points in that scenario. So that's basically the setup. And then I just need to make it so that it'll flex in the right directions. So first of all, I'm going to want to drop the dollar on the 7, so this will copy down. I'm going to want to lock in the columns here, but not the rows, so that the rows, but not the columns, so that it'll copy across, but stay in the same place. And then this one I want to lock in completely. And that should give me that. So then I guess the other thing that I did not mention but is relevant is once you've done that calculation of the different special cards you have, you then round the total down. So we're going to say round down to 0. Okay, so then I'm just realizing it might have been beneficial to have this the other way around because the suits are the other way around, but I'm just going to transpose this table instead. Transpose all of this. And you can see there's a row of zeros here because this is actually 2 merged cells, but that's fine, doesn't matter. So this is my max number, then my bid associated with that. Sorry, place this here, and then my bid associated with that. Sorry, this should be locked if I'm going to copy it around. And this is just going to be if this is less than 6, then I guess we'll call it pass. Otherwise, it's going to be this and this. Sorry, that's one formula, so I just need to kill out all the rest. So everybody passes in this one. All right, well, let's try. Okay, now we've got an actual bid, so that's good. So then the next thing is to figure out the values of those bids. Bid value, and that's going to be equals, I guess we can just do it this way. I'll say sum ifs. So I'm going to sum up these points where, actually, sorry, I can't. So I was going to do a sum ifs. I can't do that because I'm going to be summing on this and on this, which are not the same dimensions as the whole array. You know, it's actually probably easier to just add something that is the same dimensions as the whole array and then sum ifs on that. Otherwise, you could do a dynamic array sum with an if, but it's actually easier to just lay out an array there. So then let's try that again. Equals sum if. So we'll sum these points where the card is this, oops, lock, is this and this. And we don't need to worry about the less than 6s here because there is no, 4 of spades in that table, so that just won't work. So here you can see I get 60 for the one actual bid and 0 for all the rest. Okay, so now I can start answering some questions just so that you don't think I've completely lost sight of what's going on. So first of all, how many spades does player 4 have? All right, so I didn't even need to go this far for that. So L1, count ifs. These are player one's cards, and here is the spade suit. F9. And we'll take sequence, we'll do example 1, and then we'll take sequence 10, 20, 10. And then we'll just DT where the input cell is that. And then we calculate. Well, that's not good. Oh, sorry, yeah, I'm counting where it is spade. I need to count where it ends with spade. There we go. So then we'll put those in here. Those answers are wrong. What? Oh, sorry. It's because I'm counting player 1, and it asked for player 4. So try one more time. And now the answers are right. Okay, good. Next question. If clubs is the trump, how many big trumps does player 2 have? Okay, so again, I've kind of mashed a little bit too much stuff together here, but this is relatively easy to do with the setup we have. So we're going to say sum of count ifs. So I'm going to do the count ifs just like I did before. So what is it? If clubs is the trump. So we're going to count just the big trumps here for player 2, which is this one here. And that's going to give me, well, let me just lay it out. That's going to give me an array, and then, like before, I'll just sum that up. And sorry, I want to get rid of this and this. And then that's example 2, and what is it, the 20 after that? Yes. So sequence of 20 numbers starting at 11. Yes. And I'll recalc that. Okay, so that's working out. I should have mentioned, I guess, I've got conditional formatting on here, so these will turn green if the answers are right. So we're doing okay here. Okay, so the next question, what bid would the third player be willing to bid up to? And we're interested in the form of a card. So that we have, we just need to get it in the right way. So what we'll do is XLOOKUP. The highest bid can be is 500, so I'll XLOOKUP 999 on player 3's bid points, returning from player 3's bid, and I'm going to say exact match or next smaller item. So the reason I'm putting in 999 is because that'll always be greater, so it'll always just give me the result according to the largest number, which is exactly what I want. And then again, sorry, cut that down. This is L3. So then I want that for example 3 to double check, and then for 20 after that, starting at 31. And that's this. Recalc. And am I supposed to say pass or 0? Yes, pass. Okay, so that's working. Let's see if I get the answers right. Whoops. Down here. I don't. Oops. I don't know what I did there. I tried to just copy, paste a link. Okay, yes. Good, those are working. All right, so question 4, what is the highest number of points any player is willing to bid up to? So that's also kind of already set up. It's just the max of this table here. And then it's level 5, gets a little bit funkier again. So I want this for example 4 and sequence of 20 starting at 51. Sorry, no, not 20 by 51, 20 starting at 51. There we go. So we data table that on that variable again, recalculate, and let's see if those are right. And they are. Okay. So then the last question is the one that gets a little tricky. So this time players take it in turn to make bids. So I explained before about, if, let's just find an example where there's multiple bids we can play. So example 5. All right, so here each player only has one suit that they're willing to bid on. It is possible for a player to have more than one suit they're willing to bid on, but we'll just stick with this one for now. So in this case, player 1 bids first. They are willing to bid up to 9 of clubs, but they'll bid the lowest that they can. So they won't bid any other suit, but they'll start with 6 of clubs, then a 7, then an 8, then a 9. They won't go above 9. So in other words, they will bid first and bid 60. Then it goes to player 2. Player 2 is willing to bid up to this, so they can't bid their lowest card because that would be a 40 less than 60. So let me just highlight these so we can see what's happening. So player 1 bids here, then player 2 bids there, then player 3 has to pass anyway. Player 4 is willing to bid up to a 6 of hearts. That's no help because the bid is at 140. The best they can bid is 100, so they have to pass. Then it goes back to player 1. They have to beat 140, so they bid 160. It goes back to player 2. They bid 240. Back to player 1. They bid 260. And then when it comes back to player 2, they can't beat that because the highest they're willing to bid up to is the highest they're willing to bid up to is an 8 of spades, which is only 240, so they can't beat 260. So 260 should be the winning bid. Let's just double check that that is in fact the answer that we're expecting. It is. Okay. So how are we going to model that? Well, I think the best way is to kind of lay out the possible bids. So the way we'll do that is I'll say to call. I'll put pass first. Bids, points. And then I want to figure out which players can bid each one. So P2, P1, P2, P3, P4. So pass is worth 0 points, and then I'm going to say to call. Oops, up here. So take all of these. These are your possible bids. Then to call of all of your possible points. And I think these come out listed in order. If they didn't, you could like H stack them together and sort by, but as it is, so let's quickly double check. That's greater than that is true all the way down, so we don't need to do anything with that. So now, who can make what bid? Well, everybody can bid a pass, so I'll just hard code a 1 there. I'm going to make this whole row red because it's not the standard formula. And now the question is, can player 1 bid a 6 of spades? The way we're going to figure that out, I guess it would be helpful to have a suit column here. It's going to be blank here. Just say NA. And then just take right of that. So what I'm looking at is, for player 1, for suit spades, I'm basically interested in this intersection. Is it, sorry, actually, in addition to the suit, I really should have the number. And again, that's NA, and this is going to be left. This, then this, minus 1. I guess I'll put a minus minus in front of that so I can treat it as a number. So then I just want to figure out for player 1, suit 1. Sorry, again, I should have just made these numbers rather than P1, P2, P3. So now I'm going to index on here. And then my row number is just going to be the player number. Don't need to even match that. And then I'm going to X match this, lock in the column, because I'm going to copy this across against this set of suits here. Lock that in. Oops, got to delete the hashtag to lock it in. Okay, so then I can see, okay, the best the player 1 can bid on spades is 3, the best the player 2 can bid is 8, 1, 1. And so the only one of these that can bid a 6 is player 2. So what I'm going to do is I'm going to say minus minus, this is greater than or equal to this. And that'll give me a 1 or a 0 according to whether this player can bid this bid. And so now I can say, for player 1, you can't see the 1 there, but never mind. These are the possible things they can bid. So they'd be willing to bid 6, 7, 8, or 9 of clubs. And like I said, there are situations where, let me just see if I can find one of the situations where one player can bid more than one thing. That's not one. That's, yes, here's one. Okay, so, no, sorry, these are different players and the same suit. I'm interested in different suits for the same player. So, no. I'm 100% sure that this is theoretically possible, but I'm going to give up on looking for it if I don't find one pretty soon. Yes, here's one. Okay, so player 4 can bid a 6 of diamonds, up to a 6 of diamonds, or up to a 7 of hearts. So if I come look here, they'd be willing to bid a 6 of diamonds, a 6 of hearts, or a 7 of hearts. All right, so now let's figure out the actual sequence of bids. So bid, let's go player, bid. So this is going to just be 1, 2, 3, 4. And then I don't know the theoretical maximum number of rounds of bidding. I could work it out, but we're not going to need more than this, I don't think. We can always check. So then here we're going to say, actually we'll start with a bid of 0. Then we're going to say minifs. Sorry. So I want the minimum of these points where the player, so I'll index on that, rows 0 to give me all the rows, and column number is going to be this to give me player 1, where that player is 1, and where this point number is greater than the previous bid. So starting at 0, now player 1 has to bid something or else there. So 0. In this case, basically if the number stays the same, so I'll just call this new bid. If the number stays the same, it means that player didn't have anything to bid. So if you can't beat 0, then you're passing, you're not bidding at all. So then let's copy down. So we can see here, player 3 bids 40, player 4 bids 80 to get ahead. And then let's keep copying down. So 1 and 2 have passed, so they're not going to add anything. Then player 3 still can only bid 40. Okay, sorry. So I gotta fix this, because right now this is saying the bid goes back to 0. What I really want is to say it's going to be, if you can't beat the bid, then it should stay at the old bid. So we'll take the larger of what you can come up with and the previous bid. And then you can see, okay, player 3 bids 40, player 4 bids 80. When it gets back to player 3, they can't beat 80. When it gets back to player 4, they bid again. Now I need to fix that logic, because we don't want player 4 to bid again against themselves to get up to 100, to get up to 200 if they've already won. So I'll just call this leader. I'll start with X, and then I'll say if there's a new bid, then this player is the leader, otherwise that. And then center that so those line up with each other. And then here I'll say if the leader, if you're already the leader, then don't bid again. So if you're already the leader, keep the old bid, because that was your bid. Otherwise, do all this to figure out the next bid, copy down. And now we can see, okay, player 4 doesn't need to bid again because they already won at 80. So now, what is the actual question? I think it asks point value. Oops, sorry. Down here. Nope, next one down. Yes, point value or pass if there's no bid. Okay, so L5. If this final bid equals 0, then pass. Otherwise, the final bid. And then I want that for example 5 and 30 numbers starting from 71. Calc, and let's see if those answers are correct. Okay, cool. That's good. All right, so then let me quickly take a look at the bonus questions. Most common card dealt to player 1 in level 1. So I think the easiest way to do that is just to take this. Actually, I don't even need to. I'll do it here. Am I including the example or not? Games 1 to 10, not including the example. Okay, so what I'm going to do is I'm going to say filter this, where this thing that lists out my players in order is equal to 1. That gives me that. And then I want to get the unique cards, so I'll say toCall of that. I'll say unique of that. And then I will say countifs this, and then I guess I'll be formulaic about it just for good habit. I'll say XLOOKUP 1000. So in other words, again, it's that same large number trick as I did before. If you look up a large number here, returning from, whoops, sorry, forgot the comma, returning from here, and we want exact match or next smaller item. That gives me NA. That's not good. Did I do it the right way around? They're the same size. What's the problem? That's weird. Match mode, exact match, or next, sorry, I must have hit next larger. Okay, there we go, 4 diamonds. How many diamonds have been dealt to the players in total in level 4? Okay, so again, we'll come down to level 4. And what I'll do is I'll say countifs, where this is something followed by a diamond. I'll just F9 that. And where this is not K. So everything goes to a player unless it's K. And then I'll just copy that down and sum those up, and the answer is 202. I won't make you watch me go find that. And then finally, what is the total value of all the bids made in game 73? So we'll go to 73 here, and I just want sum ifs the bids where it's a new bid is true. That's 1840. Cool. I think I'm over 30 minutes on the video. I think after I net off my explanation time, I probably made it under 30 minutes. Obviously, that is, you know, having had some time to reflect on it. The reason that this one is not my live attempt, which I did for the quarterfinal and I'm hoping to share as well for the final, is because the version of this that I actually tested was significantly harder. I had a much more complicated level 5 and did not have the level 2 in between with just asking about big trumps. But my feedback on that was that that case was probably a little bit too hard. So that ended up being a little simplified. I feel like I was vindicated in that, considering that this was, even after being simplified, the lowest scoring case in the finals. But I think it was still a very nice case. So yeah, that's why you didn't get my live attempt on this one, because it was much messier. All right, that's what I got for today. I'll be back on Friday with the final. Also, I'm going to be on Rainier's channel. I'll post a link to that in the comments, with himself, Jason Weber, Brittany Deaton, who was one of the finalists, almost knocked the champion out, and Gabriella Stroy on Friday afternoon to talk about how each of us tackled some of these different questions. That's what I got for today. Thanks for watching. See you next time.